Hello, my dear student. Myself, Dr. Samir. You are watching my YouTube channel. Today, I will discuss another most interesting topic, which is method of variation of parameter. Basically, method of variation parameter is used to find pi of a higher order differential equation with constant coefficient. So, in D operator, already you know how to find pi, but here you will learn how to find pi using CF means complementary function. Okay, so here I have considered one important question and general question. Okay, so question is solve by method of variation of parameters d2y dx square a square y is equals to sec ax. Okay, where a not equals to 0. Now try to understand how to solve it. Now I'm going to the next slide to solve this problem. So now everyone please write it down the question and then try to understand how to apply this method to solve this particular problem. And please remember one thing. So here the CF part, whatever you know from your D operator method, CF part is same, but only different is PI calculation. Okay, now please write it down. So here same process. Now write down the solution. So please write down the given. Please write down the given differential equation is. So please write down d square y by dx square plus a square y is equals to sec ax, where a not equals to 0. Okay, so here you write down let y, this is number 1, let y is equals to e to the power mx be a trial solution of d square y by dx square plus a square y is equals to 0. That means on the right side part you are considering as a 0. Okay, so now you write down y is equals to e to the power mx. So dy dx is equals to m e to the power mx. Clear? And d square y, please write carefully, d square y by dx square is equals to m square e to the power mx. Clear? So now if I substitute here, we have this is number 2. So you write down from 2. So it is coming m square e to the power mx plus a square e to the power mx equal to 0. So from here you may write e to the power mx m square plus a square equal to 0. Okay, so from here you may write m square plus a square equal to 0 since e to the power mx not equal to 0. Clear? Because already you have considered as a solution, it cannot be 0. Clear? So this equation is called auxiliary equation, AE, auxiliary equation. Okay, auxiliary equation. Now we have to solve it to find the value of m. I think up to this portion is clear to everyone. just like previous method, CF part is same. Okay, so if I go back to the if I go to the next slide, it is coming m square plus a square equal to 0. It means this imply m is equals to plus minus ai. So what will be the CF? CF will be C1 cos ax plus C2 sin ax. Now I think it is clear to everyone where C1 C2, where C1 and C2 are constant, arbitrary constant. Okay, now the interesting part is here in CF. So already you know the constant C1 C2. Now in this method, that is a method of variation of parameter, so we can find pi using this CF. Now let's see. So please write down, let the particular solution be ux cos x plus vx sin x. Clear? Oh, oh. Surprise. Okay, now interesting part is there. You can see all are same, only I have replaced c1 by ux and c2 by vx. So in this case, so you may write the solution. So in d operator you are writing pi, so here you may write yp or pi also you can write, no, there is no issue. So if you want to communicate, if you want to correlate with the previous method, then you may write pi also, no problem. So ultimately, so you are considering particular integral. So here I have considered solution, so you may consider this also, ps, or in already you are familiar with pi, particular integral. Here it is ps. Okay, or you may pi you can write, no problem. Okay, so now our target to find the value of u and v. So these are the two unknown. After getting it, you should substitute here, and that will be the particular integral or particular solution of this particular problem. Okay, so this line can be written as ux y1 plus vx y2. Now I think it is clear to everyone what is your y1 and what is your y2. So here y1 is equals to cos ax and y2 is equals to sin ax. Okay, now try to understand how to find its ux and vx. Okay, and there student, there no confusion. So here we are identifying, or we are calculating pi. Okay, so you may, if there is any confusion, if you are facing any confusion, pi, should I write pi or ps, whatever, okay, we can rectify it, no problem, there is no confusion. You may write pi, and now I think it is okay. Okay, so we are creating pi, particular integral, from cf by replacing the constant part. Okay, so in my next slide I'll use some formula. So please write down where, so please write down where ux is equals to, how to find it, minus y2 x by w dx, and vx is equals to y1 x by w dx. Okay, w dx. Now, so already you know what is your y1. Y1 is equals to anyone, cos ax. What is your y2? Y2 is equals to sin ax. What is your capital X means, what is your on the right side? This one, correct? So please write down, it should be sec ax. Now, what is your w? W is equals to, you write down, that is called Waxian. That is your y1, y2, y1 dash, y2 dash. That is a derivative of it. So here in this particular problem you have cos ax sin ax. Okay, now if I can differentiate this, it is coming minus a sin ax, correct? And here it is coming a cos ax. Is it clear? Derivative of it, cos a derivative minus a sin ax, and sin ax derivative is a cos ax. So if you take already the determinant, so if I simplify, it is coming a cos square ax plus a sin square ax. So from here it is coming a cos square ax plus sin square ax. Ultimately it is coming a. Clear? So now you know everything. Y1 you know, y2 you know, x you know, w you, all are known to you. Huh? So now you write down one by one. So therefore you write down, therefore ux is equals to, you use it, minus, that is coming sin ax sec ax by a. Is it clear? Y2 is equals to sin ax and x equals to sec ax, and this. So from here we may write minus 1 by a, it is coming tan ax. Okay, so now already you know that tan ax, you have a formula, minus a is coming, so 1 a, that is your log sec ax by a. So ultimately it is coming 1 by a square log sec ax. Now if you want to absorb this negative sign, then your result will be like, so already you know log minus, this minus can absorb log, so here you may write 1 by a square log of cos ax. So now you know what is your u. Suppose you have a question in your mind, sir, you are integrating something but you are not adding some constant. Why? Because already you know uh, from the starting of the differential equation, here it is a second order differential equation, isn't it? So its solution contains, always its solution contains two constant. So in CF already we have two constant, correct? So in PI no extra constants are required. So that's why here we are not adding any constant. So now it is clear to all of you what is your u calculation. Now comes to v. Now comes to v. Very simple integration you have. Now comes to v. Now, so here you have, now you substitute the same process. So what is your y1? Y1 is equals to cos ax, it is your sec ax by a into dx. So ultimately cos sec just reciprocal of it, so you may write 1 by a, both are cancelled, that is your dx. So ultimately we have 1 by a into x. Okay, so therefore you may write pi is equals to what you have, ux cos ax vx sin ax. So you may write what is your u. So already you know, a square log cos ax, 1 by a square log cos ax into cos ax. Please use bracket properly. Now what is your vx? Vx equals to 1 by a into x sin ax. I think it is clear. Sin ax. Now our pi part is over. Now our pi part is over. Okay, so only one line is left, so please write down. Shall I move to the next slide? Just I have replaced, or you may write substituted u part and v part, and we have mentioned in the within bracket, correct? Now, so write down the required solution is y is equals to CA plus PI. So your CF is equals to C1 cos AX plus C2 sin AX plus 1 by A square log of cos AX into cos AX plus 1 by A into X sin AX, where C1 and C2 are arbitrary constant. Okay, I think it is clear to everyone. Okay, the only here we can this is another approach. Just you remember, this is another approach. Okay, and these are direct forward. Here I have used direct calculation, but those who are in honors, whatever the formula I have used here, especially Vx and Ux calculation, those who are belongs to honors, you have to create this formula first, then you can apply it, otherwise not. Okay, but in engineering, no need to create this formula, you can directly apply it. Okay, thank you everyone. Please do subscribe my channel, and please follow and share this video to all of your friends so that they can get some benefits. Okay, thank you.